So let's look at a systematic way to balance chemical equations. This three-step approach is a systematic way, and the first thing we want to make sure of is that we have the correct formulas for our reactants and our products. So our subscripts are going to be correct, and then if the physical states are given, we want to include those. Next, we want to look for an element that appears in only one reactant and one product, and balance that first, and then choose coefficients to balance the other elements as needed. If I have a chemical that is an element, then I want to balance that last. So in this chemical equation here, I have an element. Here's hydrogen. It's the only symbol in this formula. It's an element. So I want to balance that last. Now I look at carbon. It's in one reactant and one product. It's already balanced. There's one on each side. Nitrogen on one reactant and one product, and it's already balanced. So I've got to move on to hydrogen. Hydrogen has 4 plus 3, a total of 7 on the reactant side, and 1 plus 2, a total of 3 on the product side. So how can I balance that? I want to try and balance my hydrogen by changing the coefficients of the element, because my carbons and nitrogens are already balanced. If I try and balance my hydrogen by placing coefficients in front of any of the other chemicals, then I'm going to change my number of carbons and nitrogens and unbalance those. So if I place a coefficient of 3 in front of the hydrogen, I'll have 3 plus 1, which will be 7, and then I'll have a balanced chemical equation. So let's look at a more complex example. So let's count the atoms in this chemical equation. For nitrogen on the reactant side, I have 1 times 1, which is equal to 1. For nitrogen on my product side, 1 times 1, 1. So my nitrogens are balanced. Hydrogen on my reactant side, 1 times 3 is 3. And on my product side, 1 times 2 is 2. So my hydrogens are not balanced. And then my oxygen on my reactant side, 1 times 2 is 2. And then 1 times 1 is 1. Plus 1 times 1 is 1 for a total of 2. So let's look at balancing my hydrogen, since that's not balanced. On my reactant side I have 3 hydrogen, on my product side I have 2. So if I place a coefficient of 2 in front of my ammonia, I will then have 6 hydrogen. And if I place a coefficient of 3 in front of my water, I will then have 6 hydrogen. So that balances my hydrogen. However, when I place that coefficient in front of the ammonia, that also changed the number of nitrogens I had. So let's look at that. I now have 2 nitrogens on my reactant side. So I want to have 2 nitrogens on my product side. So I'll put a coefficient of 2 in front of that nitrogen. So now my nitrogens and hydrogens are balanced. However, when I put this 2 in front of my nitrogen monoxide and that 3 in front of my water, that changed the number of oxygens I've had. So let's look at that. I now have 2 oxygens from my nitrogen monoxide, and I now have 3 oxygens from my water. So that gives me a total of 5. So how can I get 5 oxygens on my reactant side? Well, if I multiply 2 by 5/2, I can get 5. However, in general, using fractions is frowned upon when we balance chemical equations at this level. We can look at these coefficients as meaning molecules, which in that case the fraction won't make sense, or in terms of moles, in which case the fraction would make sense. However, we don't want to use fractions if we can avoid it. So how do I get rid of this fraction? Well, I can clear the fraction by multiplying 5/2 by 2, and I'm allowed to do that as long as I multiply every other coefficient by 2 as well. So if I multiply 2 by 2, I get a coefficient of 4, 5/2 times 2, coefficient of 5, 2 times 2, coefficient of 4, 3 times 2, coefficient of 6. So let's check to make sure it's balanced. So I'm going to multiply, oh gosh, I'm so sorry. I'm going to multiply for nitrogen a coefficient of 4 times 1, which will give me a total of 4 nitrogens on my reactant side. On my product side, 4 times 1 gives me 4. So my nitrogens are balanced. For my hydrogens, 4 times 3 gives me a total of 12 hydrogens on my reactant side. And then on my product side, 6 times 2 gives me a total of 12. So my hydrogens are balanced. My oxygen, 5 times 2 gives me a total of 10. And when I look at my oxygen on the product side, 4 times 1 is 4, and 6 times 1 is 6. So 6 plus 4 gives me a total of 10. So my equation is balanced. So this is really messy looking, and sometimes balancing equations can be really messy. Whenever we change the coefficient of a compound, then that coefficient will change the number of both elements, or all the elements. So we just have to go back and forth, and eventually it will become balanced. Now, not only are fractions frowned upon, but also when we have our final answer for a balanced chemical equation, the coefficients should not have a common factor except for 1. So I notice here my coefficients of 4, 5, 4, and 6 do not have a common factor other than 1. Sometimes we can balance chemical equations, especially if we're going back and forth, in pretty large numbers. For example, if I balance this chemical equation with coefficients of 8, 10, 8, and 12, my equation would still be balanced, but I would have a common factor of 2. So I would want to divide out that common factor of 2 to get these coefficients that have no common factor other than 1.